In this demonstration, I want to show you how quick and easy it is to set up HiPer DevGen, which is Tenor EDA's high-performance device generator. For this demonstration, we're using HiPer DevGen integrated into version 15 of Tenor EDA'sLedit layout environment. I think most layout people, or certainly most designers that do any sort of layout, are familiar with the idea of parameterized cells. What most people may not realize, however, is the upfront development cost that is required to develop these parameterized cells. For any technology node and for any tool set, there is an upfront development cost to actually code these parameterized cells so that you can accelerate the full custom flow later on. In this example, I just want to show you a very simple MOSFET T-cell, which is a parameterized cell in the Tanner environment. What you can see from this window is that this T-cell is written in C. So there's an upfront coding cost that the layout engineer typically doesn't do. It's handed over to a CAD department. But this coding, in this case C, this coding is very much tied into a specific vendor, which in this case is Tanner EDA, but also a specific technology node. So anytime a company wants to move to a new technology node, they have to invest this upfront cost in coding their parameterized cells, or certainly developing their parameterized cells. However, obviously for this once-off cost per technology node and per tool set, what it does give you is it gives you a very, very accelerated full custom layout flow. As an example here, this MOSFET, if I bring it into our drawing canvas over here and create a MOSFET of, let's say, 20 microns with 3 fingers, and I click OK, what we end up with is we end up with a DRC and LVS clean MOSFET device, which can be used from there on in to create the rest of the structure. So we certainly get a significant acceleration that we wouldn't have if we had to lay out this device by hand. And this acceleration is fine, but it is tied to that once-off investment in developing these P-cells. So what we're trying to do with HiPer DevGen is we try to make it in such a way that there is no coding, you are not tied to a technology node, so any physical designer, regardless of what technology node they're on, they should be able to use HiPer DevGen more or less straight out of the box with a very minimal setup effort. And I'm going to show you that example now in this demonstration. So what we have here is we have a different technology. I'm just going to close the old technology which has the Tanner T-cells. And in this technology here, on the left-hand side, we can see that we have our basic layers, NML, Poly, P+, Diffusion, and so on. Obviously, these layers can be rendered in any color you want, and they can be called any name you want. In the Tanner environment, to set up HiPer DevGen, you go up to Cell, DevGen T-cell, and you set up HiPer DevGen process information, which brings up a nice GUI. And the first thing in this GUI you need to define is the number of metal layers. HiPer DevGen currently supports anything between 3 metal layers upwards, but you do require a process that has at least 3 metal layers. Once you tell it how many metal layers you have, the next thing you need to do is you need to map HiPer DevGen internal layers to your physical layers that you're using in your environment. So as an example, the second box here, diffusion. We call it the source drain diffusion or oxide definition layer, and we map it across to diffusion here. Obviously you could have called this OD, active, or whatever other name you want to give it, but you just map it to this one. And this mapping is a very, very straightforward process where you just map the layers across. Once the layers themselves are mapped, the next thing you need to do is you need to feed in the physical design rules for the technology node that you're on. So in this case, starting off with minimum poly width, you need to tell it what the minimum poly width is for the technology. In this case, we're on a 0.25 micron technology. You give the maximum channel length, or channel width, excuse me, the minimum poly spacing, and so on. And you go through each of the forms and you fill in all the design rules. Obviously, the number of design rules will scale depending on the number of metal layers you are and the technology you're on, but the process here is a one-off setup process that takes 15 to 20 minutes. But it's very, very quick to do. More importantly, you can go back at any stage, you can change the numbers, and once it's done, what you'll end up with is you will end up with a parameterized cell that straight away on the technology you want to use is going to be DRC and LVS clean. So as an example, this is a HiPer MOSFET, or a MOSFET generated by HiPer DevGen. We can specify the width and length of the device. Let's go for, let's say, a 10 micron device over 0.25. We can specify the number of fingers, let's say 3. A nice little thing here is as we change the number of fingers, down here we should be able to see that the join multiple fingers option will come on or become disabled depending if you have multiple fingers or not. And it's quite feature rich in terms of where you want your gate connections. Let's go top and bottom, and let's add a guard ring all the way around. So effectively what we have here is we have a very simple MOS device. All the layout person has had to do is 15 minutes is for this technology, map the technology layers across and also enter the design rules. And the minute that is done, they now have silicon aware parameterized cells. At any stage, obviously, we can go back and we can edit this guy. In this case, we have the fingers are not joined. We can click this and we now get a device where the drains and sources are joined to each other with a guard ring all the way around. So, as you can see, or hopefully what you can see from this demonstration, is the setup is very, very, very minimal. It's completely GUI driven, and with a 15-20 minute effort, you straight away, for effectively no cost, have parameterized cells on your technology that your layout people can use time and time again.